In this step, we're going to solve exponential equations. Well, what makes an equation exponential is that x is in the exponent. The variable is in the exponent. And what makes it an equation is that there's an equal sign. So, to solve exponential equations, the key in the first step is to have a common base. If we have a common base, then the two sides of the equation are going to be equal to each other if and only if the exponents are equal to each other. So if we have a common base, then we can set the exponents equal to each other and then solve for x or whatever variable was originally in the exponent. So let's look at this first example. Solve 5 to the x equals 5 to the third. Well, we have a common base of 5. Therefore, this equation is only going to be true if x equals 3. 5 to any other power is not going to be equal to 5 to the third. So if we check and I sub 3 in for x, then my equation is going to say 5 to the third equals 5 to the third. Something equals itself. We can type into our calculator to find that 5 to the third is equal to 125. 125 is equal to 125. This equation is balanced when x. To solve exponential equations without logarithms, you need to have equations with comparable exponential expressions on either side of the equal sign, so you can compare the powers and solve. In other words, you have to have the same base to the set. In other words, you have to have some base to some power equals the same base to some other power. Base power equals base power, where you set the two powers equal to each other and solve the resulting equation. So same base, set the exponents equal, and solve. So let's do another example. 10 raised to the x minus 1 equals 10 to the fourth. Both equations are base 10. So I can set the exponents equal to each other. This is only going to be true if the two exponents equal each other. And I got x to equal negative 3. So let's check our work. We always check by starting with the original equation, 10 to the 1 minus x equals 10 to the 4th. So I'm checking that x equals negative 3 will balance this equation. So I'm going to replace x with negative 3. 1 minus negative 3 is 1 plus 3, which is 4. And I have 10 to the 4th on both sides of my equation. Therefore, x equals negative 3 is the correct answer. Now, not all exponential equations are given in this. Not all exponential equations are given in terms of the same base on either side of the equal sign. Sometimes we first need to convert one side or the other, or both, to some other base before we can set the powers equal to each other. So if we do not have the same base given to us, then we need to find a common base. So on the left-hand side, I have base 3. And on the right-hand side, I have a 9. My goal is to convert 9 into base 3. Well, 9 equals 3 squared. That's a pretty common one that we should know. So let me rewrite this as 3 to the x power equals, instead of writing 9, I'm going to write 3 squared, because 9 is equal to 3 squared. Now I have the same base, so I'm going to set the exponents equal to each other and solve. It's already solved for x. So this is true when x equals 2, and this is an easy one to check, because if I sub 2 in for x, 3 squared is in fact 9. I've included a table here for you to use when you're trying to figure out if something has a common base, if a number has a common base. So this is bases 1 through 10 and powers 1 through 10. So we would be looking at the numbers on the right-hand side and rewriting them as the numbers on the left-hand side, the base and the power. So let's try another one. 3 raised to the 2x minus 1 equals 27. So I have base 3 on the left-hand side, and my goal is to convert 27 into base 3. So I'm going to look at the chart, and 27 is equal to 3 cubed, 3 to the 3rd power. So I'm going to rewrite 27 as 3 to the 3rd power. So this is step 1, get a common base. Step 2 is set the exponents equal to each other. And step 3 is solve. I found x to equal 2. I'm going to check that. 3 raised to the 2 times 2 minus 1 equals 27. So I have 3 to the 4 minus 1 equals 27. 3 cubed equals 27. 3 cubed is 27. So I've got 27 equals 27. X equals 2 is the correct answer. The goal is always going to be try to turn the bigger number into the smaller base. So I'm going to see if I can turn 81 into base 3. 81 is 3 to the 4th. So I've completed step 1. I've got a common base. Step 2 is I'm going to set my exponents equal to each other and solve. Notice that this is a quadratic. So there are different ways you could solve this. You could put both equations into your graphing calculator and find the points of intersection. You could do the same thing on Desmos, or we can solve by hand. And I'm going to check if factoring will reveal the solutions. So I'm going to move the 4 to the same side as all the other terms. And as we know, to factor, we're going to multiply a times c, 1 times negative 4. Find the factors. Choose the 2 that add up to get the b term, which in this case is negative 3. So 1 minus 4 will equal negative 3. So my factors are going to be x plus 1 and x minus 4 still equals 0. And if we're multiplying 2 terms together and we get 0, must mean one of the 2 terms equals 0. So that'll be true if x equals negative 1 or 4. So now we've got 2 solutions. X equals negative 1 and x equals 4. So let's use our calculator to check this time. I'm going to store negative 1 as x by hitting negative 1, the store button, x, enter, and then I'm going to type in 3 raised to the x squared minus 3x. And when I do that, I get 81. So negative 1 is a correct solution. And let's check 4. So now I'm going to hit 4, store as x. And instead of retyping that same equation, I'm going to hit second, enter, and again I get 81. So these are both solutions to this equation. This equation has 2 solutions. Let's try another. So I've got base 81 and 9. Well, I know that 9 squared is 81. So I rewrote 81 as 9 squared. Well, when I have an exponent raised to another exponent, we know from our exponent rules that we multiply the exponents together. That's the power rule. So I'm going to distribute this 2. So here I've completed step 1. I've got a common base of 9. So now I'm going to go on to step 2, which is set the exponents equal to each other. Step 3, solve. And I got x to equal -1. Again, I'm going to use my calculator to check. And when I sub x equals -1 into both sides of this equation, I get the same number back, 0.0123, 4, 5, 6, 7, 8, on both sides. Therefore, the equation is balanced when x equals -1. The left side equals the right side. And let's do one more. 256 and 64. Let's go look at the chart. 256 and 64. So I see a 64 and a 256 here. I also see one under the 2's. Combination under the 2's, so I could rewrite 64 and 256 as base 2, or I could rewrite them both as base 4. Either way, you will, if you solve correctly, you'll get to the correct answer. So I'm going to rewrite as base 4, 4 to the 3rd and 4 to the 4th. So 64 is equal to 4 to the 3rd and 256 is equal to 4 to the 4th. So I rewrote 256 as 4 to the 4th and brought down the exponent. And I rewrote 64 as 4 to the 3rd and brought down the exponent. When I have an exponent raised to an exponent, I multiply them together. Solve and I get x equals 11, and when I check using my calculator, I get the same decimal on both sides of the equation, 1.329 approximately.